Okay, we'll continue with gypsum products. Last time we have seen about what is gypsum, what is plaster, how to convert gypsum into plaster or plaster into gypsum, and what that process is called, and properties of gypsum. Now we'll continue with setting time. So we'll see in brief about whatever we have seen in last lecture. So what is gypsum? Gypsum is calcium sulfate dihydrate. When it is converted into, when it is heated, it converts into calcium sulfate hemihydrate, that is plaster. Then again, plaster is mixed with water, so it regains 1.5 molecule of water and it again convert into gypsum. So when gypsum is converted into plaster, that process is called as calcination. Then there are different theories of setting a reaction. Most widely accepted is crystalline theory, that is given by Chatelier. So now setting time. So we have seen about setting time, that what is setting time, mixing time, working time. But again, we'll start from the starting. So setting time is what, setting time again is divided into two types. That is mixing time and working time. Mixing time is the time when we start mixing or adding plaster into the water. It's called as mixing time. And working time is the time available, a workable mix, that is the mix which we can pour or we carve, that is called as working time. So setting time is what, basically setting time is a combination of mixing and working time, that is the time elapsing from the beginning of the mixing to material hardens is called as setting time. So there are two types of setting time again, initial setting time and final setting time. So initial setting time, in the initial setting time, as the reaction proceeds, however more hemihydrate crystal react with a react to form a dihydrate crystal. So how hemihydrate converts into dihydrate? So basically we mix gypsum, sorry, plaster into the water. So it forms suspension. So that suspension is the solubility of hemihydrate and dihydrate are different. So hemihydrate is more 4 times more soluble than dihydrate. So it forms supersaturated solution, and any supersaturated solution is unstable. So it precipitates out dihydrate crystals. So this process continues till all the hemihydrate is converted into dihydrate. So initial setting time. As the reaction proceeds, however, the more hemihydrate crystal react to form dihydrate crystal. The viscosity of the mass is increased and it can no longer be poured. The material becomes rigid but not hard. So material becomes rigid but not hard. So it can be carved but not molded. This is known as initial setting time. And final setting time, it, in final setting time, material becomes hard and we cannot carve or mold. So in initial setting time, we can carve or mold the thing, but in final setting time, it is not done. So what is final setting time? The time at which the material can be separated from the impression without distortion or fracture. So this is final setting time. So measurement of setting time, we have seen about this loss method, exothermic reaction and penetration test. In penetration test, two types of tests are there, and that is Wickett needle and Gilmore needle test. So loss method is when we mix plaster with water. So the mixture is glossy, but when the mix is fully setted, then the gloss is lost because of water is evaporated from the mixture. Then again the reaction is exothermic. So when the temperature rise, the mass may also be used for the measurement of the setting time. So in penetration methods, there is Wickett needle and Gilmore needle. Wickett needle give final setting time. Gilmore needle, two types of the needle are there, small and large. Sorry, in Wickett, small and large type of the needles are there, and in Gilmore needle, it gives only one type of the setting time. So now the factors affecting the setting time. So you get question on this topic, that factors affecting the setting time. So here there are different factors like manufacturing process, mixing and spatulation, water powder ratio, temperature and modifier. In manufacturing process, it is not in our hand, as the manufacturers have rights to incorporate impurities, not exactly impurities, but he can decide that how much hemihydrate should be there and how much dihydrate. When dihydrate is present, it acts as a nucleating agent and it accelerates the reaction and it fastens the setting. So more the dihydrate is there, then it is again it depends on the manufacturer. So it is controlled by the operator. So the factor controlled by the operator are temperature, water powder ratio, mixing and modifiers. So the manufacturing process, again here impurities. Impurities is as in gypsum. Gypsum is what, again, when the calcination is not complete, so the gypsum particle remains, or if the manufacturers add gypsum, the setting time is shortened. So gypsum is what, basically it is dihydrate. So when there is dihydrate present, it accelerates the rate of setting. So this is again one of the factors. Then fineness. Finer the particle size of the hemihydrate, faster the mix hardens, and more rapid is the crystallization output. So mixing and spatulation. Again, within a limit, longer and faster. Within a limit, we can do spatulation. So it again fastens the reaction. Uh, so what exactly happens here is, when we mix the plaster into the water, we distribute the dihydrate crystals. Basically, we mix hemihydrate with the water, but there are some amount of dihydrate crystals, and we evenly spread that dihydrate crystals. Again, that dihydrate crystals act as a nucleating agent and fastens the setting reaction. Again, the water powder ratio, uh, it is obvious that when the water is more, the setting is prolonged. So temperature. If the temperature of the mix increase beyond 50 degrees Celsius, retardation of the setting time occurs. So when we increase the temperature, the retardation of the setting is occur. So 50 degree Celsius to 100 degree Celsius converted back to the hemihydrate. And when it is up to 100 degree Celsius, there is no reaction takes place. Then modifiers. In modifiers, there are accelerators and retarders. Accelerator helps in fastening the setting reaction, and retarders helps in slowing the setting reaction. Again, it is depend on the operator. So if you are mm, fluent in handling the product, then we can add the accelerator. But it is again not in our hand. The operators, whatever the manufacturer decide how much accelerator is needed and how much retarder is needed. So the modifiers are the chemical. Modifiers are the chemicals added in order to alter the some of the properties and make it more acceptable to the dentist. The chemical added, it decreases the setting time. It is called accelerator, and if it is increase the setting time, it is called as a retarder. So here accelerators. So accelerator, again, finely powdered gypsum. It gypsum itself act as a accelerator. In low concentration, we can add sodium sulfate, that is 3 to 3.4%, then potassium sulfate 2 to 3%, and sodium chloride is added. Then in retarders, again we have higher concentration of sodium chloride. See, when you add sodium chloride within limit, it acts as a accelerator. But if you add more in the amount, it acts as a retarder. Again, then sodium chloride, sodium sulfate above 3.4% act as a retarder. Acetates, borates, citrates, tartarates, and inorganic salt like ferric sulfate, chromic sulfate, and aluminium sulfate. Then in retarders, again borax, 1 to 2% is the most effective retarder. Colloids such as gelatin, glue, agar, coagulated blood, etc. act as a retarder. Then setting expansion. See, there are two types of the setting expansion: normal setting expansion and hygroscopic setting expansion. In normal setting expansion, it is 0.05 to 5%. So all gypsum products show linear expansion during the setting due to outward thrust of the growing crystals during the setting. So when gypsum is when setting reaction occurs between the water and plaster, so the dihydric crystals precipitate out. So that causes the outward thrust of the growing crystal, and because of that, there is setting expansion. And this type of setting expansion is again the normal type of the setting expansion. So the setting expansion without water immersion is called normal setting expansion. So when whatever the amount of water is required for the mixing, that time whatever the amount of setting expansion occurs, that is normal setting expansion. Whereas when you keep that product under the water for setting, then whatever the amount of expansion occur is called hygroscopic expansion. So the setting expansion is because of crystal interlocking and hydrostatic pressure that develops in water during the setting. So what is hygroscopic expansion? If the setting process is allowed to occur under the water, the setting expansion may be more than double in magnitude. So whatever the product, whatever the mix you make, that product is kept under the water, that time the expansion occur, that is called as a hygroscopic expansion, and that is double in magnitude. Reason for increased expansion is additional crystal growth permitted by allowing the crystal to grow freely. So water gives a free medium for the free growth of the crystal. So whatever the outward thrust of the crystal is present, that is more. So the setting expansion in case of a hygroscopic case, there is more. So rather than being constrained by the surface tension with the crystals forming the air. The basic mechanism of crystal growth is same in both. Both the phenomena are through setting expansion. So here you can see the normal setting expansion. Here the crystal, here you can see the outward thrust of the crystals here, whatever the amount of setting expansion occurs. And here in when you keep that product under the water, so you get a free medium. Whatever the crystals are growing, get a free medium, and uh, there is more expansion, that is almost double in magnitude. So now control of setting expansion. So increase setting expansion, increase spatulation, or when you add sodium chloride or dihydrate crystal or brown gypsum. So that helps in increasing the setting expansion. And reduce expansion is increased in water powder ratio modifiers like potassium sulfate, sodium chloride, and borax. So importance of setting expansion. So it is undesirable in impression plaster. So it is again depend on the classification. When you take type 1 plaster, that is impression plaster. Here in case of a impression plaster, we don't need any expansion, because we need whatever impression we are taking should be accurate. It should not expand. So for plaster, dental plaster, impression plaster, and stone, we don't need setting expansion. So it is undesirable in case of impression plaster, dental plaster, and stone, as it will result in inaccurate cast or change in a occlusal relation if used for mounting. So increased setting expansion is desired in case of an investment material, as it helps in to compensate the shrinkage of the metal during casting. So casting is a process where we fabricate that crown or bridges. So for that we need the investment material. So when we heat that metal, it expands. But when it hardens, it will shrink. So for compensating that shrinkage, we require setting expansion. So strength, again the strength is increased rapidly as the material hardens after the initial setting, expressed in terms of a compressive strength. The compressive strength is inversely related to water powder ratio. More the water powder ratio, less is the strength. So factor affecting strength, the free water content. The greater the amount of water, free water in the set stone, the less is the strength. So again, strength is two type: wet strength. Wet strength is also called as a green strength and dry strength. The strength when the excess free water is present in the set gypsum, and dry strength is the strength of the gypsum when excess water is lost due to evaporation. It is up 2 or 3 times greater than the wet strength. Mm, Temperature. So temperature, gypsum is stable only below the 40 degrees Celsius, as we have seen that above 50 to 100 degrees Celsius, the setting reaction is slow, and at 100 degrees Celsius there is no reaction at all. So the gypsum is stable only below 40 degrees Celsius. Loss of water of crystallization occur rapidly at 100 degrees Celsius, shrinkage and reduction in a strength. So water powder ratio, the more the water, greater will be the porosity and less the strength. So whatever the excess amount of water is present, the reaction is exothermic, water gets evaporate, there is void, and void act as a area for the fracture concentration. So more the water, greater will be the porosity, and more will be the less will be the strength. Again, the spatulation within the limits, the strength increases with increased spatulation. Addition of accelerator and retarders, both uh, reduces the strength of the product. So effect of water powder ratio on the compressive strength of the gypsum. Here they have given the water powder ratio for particular product and the strength of the that particular product. So here in case of a model plaster, there will be a water powder ratio of 0.45 and strength will be 12.5. But in when you see about dental stone, there is less water powder ratio, that is 0.24, and the strength will be 3.8. So more the water, less is the strength. Then tensile strength. Gypsum is brittle material, thus weaker in a tension than compression. So the one R of the tensile strength of the model is approximately 2.3 MPa. When dry tensile strength doubles. Tensile strength of the dental stone is twice than that of the plaster. So here again, when you see the classification, the strength of the impression plaster is less, and the strength of the type 4 is more. So here the strength decreases as the according to the classification. So hardness and abrasion resistance. This is related to the compressive strength. The higher the compressive strength of the hardening mass, the higher the surface hardness. The hardness of the gypsum product is increased by impregnating the said gypsum with epoxy or methyl methacrylate monomer. So impregnating said gypsum with resin increases the abrasion resistance. Reproduction of the details. The gypsum gypsum dyes do not reproduce surface detail as well as electroform dyes or epoxy dyes, because surface of the said gypsum is porous and on a microscopic level. Air bubbles are often formed at the interface of the impression and the gypsum cast because freshly mixed gypsum does not wet some rubber impression material well. So the incorporation of some, this is not for you people. Type 1 impression plaster. Huh? Again, in type 1 impression plaster was one of the earliest impression material in dentistry. Nowadays, we don't use impression plaster. So before it was used. So fracture to remove it from the undercut. So the impression plaster is very brittle material. So in case of there is undercut, it fractures easily. So it is one of the drawback of this material. The fractured pieces were then reassembled outside and the cast was poured. The plaster is primarily restricted to final or wash impression in the construction of full denture. So model plaster, that is type 2. So this model plaster is or laboratory type 2 plaster is now used primarily to fill the flask in the denture construction when setting expansion is not critical and strength is adequate. So the model plaster is used for the plasking. Then dental stone or type 3 plaster, it is intended for the construction of the cast in fabrication of a full denture that fits soft tissue. Then dental stone with high strength, that is type 4. It is synonymous to the diastone. Diastone is the strongest and hardest variety of the gypsum product. So it is used when the surface hardness and high strength is required. Example for the dies used in leg, crown and bridge wax patterns. So type 5 or dental stone with high strength and high expansion. This is used for the casting purpose, higher the compressed strength than the type 4. Improved strength is attained by making it possible to lower the water powder ratio even further. Setting expansion is increased from maximum 0.1% to 0.3%. This is for compensating the shrinkage of the base metal alloys during the solidification. So typical properties of the 5 types of the gypsum product. Here they have given the chart mentioning the properties. So water powder ratio for the, again here they have given the water powder ratio, then setting time, then setting expansion and compressive strength. So here in case of plaster, more water is required. So there is less strength, and the setting expansion is 0.15. But in case of here you see with type plaster impression, there is more water powder ratio and more is the expansion compared to the type 4, that is dental stone. The water powder ratio is less and the expansion is less. But in case of a type 5, the water powder ratio is less but the expansion is here. We need more expansion for the casting purpose. So here again the expansion is increased. Then synthetic gypsums. So synthetic gypsums are alpha and beta hemihydrate, are made from the byproducts or waste products of phosphoric acid production. So in Japan and Germany have been succeeded in its production, and but the drawback of this technique is it is more expensive. Now care of the cast. So when you pour the gypsum, uh, when you pour the cast with a gypsum product, so it has been soaked in a slurry water. If the cast is washed in a ordinary water, the surface layer may dissolve. So for that purpose, they have recommended slurry water. So again, infection control. Infection control, for infection control, we need iodophores sprays. Impression in immersion in disinfectant. So we have to immerse whatever the cast or the model is there. We have to immerse into the disinfectant. Overnight gas sterilization is recommended. 1:10 dilution of 5% of the sodium hypochlorite for 30 minutes. Ethylene oxide can be used for the disinfection, disinfectant as a disinfectant. Now, to summarize the topic, the gypsum is a unique dental material which is easy to manipulate and set hard and strong mass. Because of its property, it is widely used in a dentistry, medical, and for a general purpose such as a construction and statues and other routine uses, etc. Gypsum products are immensely useful in dentistry in general and prosthodontics in particular. So this is all.